This is the review for 8.3, so make sure you're looking at the right one. It should say 8.3 review on the top. It started out with some vocab, so let's see if we can figure these out. A convex polygon is C. That's where no line that would be extended would go inside the polygon. Concave is just not convex, so that would be K. Equilateral is when all the sides are the same.
So just the 4 points for now?
Yes. Do you guys see when where all the sides are the same? E is when it's regular, so we can fill that in. Polygon whose sides are congruent. F.
Oh.
And if it's the angles are congruent, I feel like I just saw that one too. Oh, I is equiangular. So if all the sides are the same, it's equilateral. If all the angles are the same, it's equiangular. If it's both equilateral and equiangular, that's when it's regular. So I think we have those good. The amount of surface covering a figure, that's the area. The sum of the interior angles is the n minus 2 times 180 formula. If you have that same formula and divide it by n, that's the measure of one of the angles of a regular polygon. So that's J. Pay close attention to that. That formula, number 8, was never actually in our notes. However, we did use it on one of the worksheets. The 8.2 worksheets, we used that formula on those worksheets. So just double check that one. It's not really one you can find in your notes. The exterior angles always add to 360, so that's G. Side squared, that's the area of a square. And then the area of a rectangle is length times width. So I'll leave those up there for a second. If you need any more explanation on any of these, just let me know. These words will all be on the quiz tomorrow, though, so make sure you're studying them. Convex or concave. Remember, convex is if you would extend all the sides, and none of those lines would go into the figure. Or I told you, think about it, if all the vertexes are pointing out, vertices is actually the plural. If they're all pointing outwards, then you could say convex. So this one's convex, excuse me. But this one down here, do you see how if you extend it, now you're inside the figure? Or if you extend this one, now you're inside the figure? That's when it's concave. Or you can just look at it and see that it's kind of like pointing inward, right? That's when it's concave. Any questions? Okay. Number 14, we are saying either equilateral, equiangular, or regular. Equilateral is when all the sides are the same. Equiangular is when all the angles are the same. And regular is when it's both. So number 14, what would that be? Regular. Number 15, what are you thinking? Equiangular. The sides are not all the same, so we can't go equilateral or regular, but all the angles are the same, so equiangular. And then the last one? Equilateral. All the sides are the same.
What do you have done there?
Just to throw you off a little. The question was, why is there a none? I don't know. I don't want you to think it's definitely one of those three options. None just kind of makes it a little trickier for you. See if you really know what you're talking about.
Are you sure?
Any questions? Did I miss something?
No.
No? Okay. All right. On the back, we're looking for the sum of the measure of the exterior angle of each polygon. That's where you do the n minus 2 times 180 thing. And n is the number of sides. So count up the number of sides. 1, 2, 3, 4, 5, 6, 7 sides. So if n equals 7, we're going to do 7 minus 2 times 180. That's 5 times 180, which, yes, is 900. So 900 degrees is the sum of those angles. Any questions? All right, same thing on the next one. We have 1, 2, 3, 4, 5, 6. So n equals 6. 6 minus 2 times 180 is, yes, you are correct, 720. Now, I cannot tell you how many times we do stuff like this on the board. We do it again, we do it again, we do it again, and then during the quiz, someone is like, well, how do I type that into my calculator? Practice, it's not one specific person. Practice now. Practice how to type this in now. That's why we have these review days, all right? So don't come tell me tomorrow that you're not sure how to type it in the calculator, because that's exactly what we're checking for today. So make sure you're not just taking our word for it. Make sure you're actually typing these in, seeing if you get the right answer, and asking me now if you're not. All right, so the way you do this one, first you have to find out what all the angles add to. So we're going to do just like on the last section, to find the sum of all the angles. Then we're going to subtract all the angles that we know. That'll tell us the one that we don't know. All right, so I have 1, 2, 3, 4, 5, 6 sides. So n equals 6. 6 minus 2 times 180. That's like 4 times 180, which was 720. We just did that one. So all together, all of these angles are going to add up to 120 degrees. I need to subtract the 5 angles that I know, and that will leave me with the 1 angle that I do not know. I do believe you get 65 on this one. So again, first you have to find the sum of all the angles. That's the old n minus 2 times 180 formula. Count up the number of sides. We got 6. 6 minus 2 is 4. And 4 times 180 is 720. If they all add up to 720 and you know all but one of them, you can subtract all those to find the missing one. Any questions? Now, you might not need the n minus 2 times 180 for number 20, because we did a whole chapter on this. If it has 4 sides, it adds to 360. If you forget that, though, this formula still works, because you would get 2 times 180, which is still 360. So whether you need to do this or not, it's really up to you. 4-sided figures, though, they always add to 360. Either way, though, we start with 360, we subtract 85, we subtract 120, we subtract 70, and you do get 85 as that missing angle, angle A. Questions? When you are finding area, you're doing length times width, so 2 times 8 equals 16. We're talking about area, so put a little square on the units. Number 22, though, I only see one number, so what should I do on 22? That if you multiply it by 4, that would find the perimeter. We want to find the area. So you... yeah, basically, he said, well, it's length times width, so you'd multiply that number twice. In math, we call that squaring something. Anytime you're finding the area of a square, you just take the side length and you square it, which is just 2.5 times 2.5. Does anyone know what 2.5 times 2.5 is? No. No. It's 6 point something. Just use a calculator. I don't know why. Okay, 6.25. Thank you. Talking about area, so square the units. Alright, so that is actually the end of the regular quiz. I'm going to show you how to do the bonuses as well, just in case you feel super ambitious tomorrow. The exterior angles always add to 360. So we're going to do 5x plus 86 plus 106 plus 98 equals 360. These are like terms, so we can add them together. So we have 5x plus, let me type that in, 86 plus 106 plus 98, 290.
Can you subtract all of them and then take the 5x and divide it?
Yeah, so if you want to subtract one number at a time, you can. I just like to combine like terms and then subtract the big number. But yeah, either way, you should get 70 on the other side. So 5x equals 70. And then when you divide both sides, you get that x equals 14. What are your questions? Alright, you can see in the directions the hint is that these are regular figures, B and C. When they're regular, remember they're equiangular and equilateral, so on part B we're just going to set the angles equal. And in part C we're going to set the side lengths equal. And then on both of them you're just solving for the x. Alright, so on this one, you're going to get x equal 5.
So basically for B, you just divide.
Mm-hmm. Yeah, you just isolate the x using inverse operations. So if it's times 3, you divide by 3. On C, it's a two-stepper, so we have to add the 6 and then divide by the 3. So that is the gist of your quiz. The quiz is tomorrow. Any additional questions?